Today we start the unit number 4 of the drug and dyes. 4.1, last unit of the drug and dyes. Color and chemical constitution of the dyes. So color of the light, color of the particular dyes is visible only because of the wavelength of the light absorbed and reflected by that particular material is fall under the region of the visible region. We know that the visible region having the wavelength range of the 400 to 800 Armstrong, and in between that region, if the light of having the wavelength that is really visible to us, means the retina of our eye is capable to distinguish that particular wavelength of the lights, means this is the visible to us. So the rays are arranged in the between the visible regions are on the center, because if wavelength is increases, then it will goes on IR radiation, which on increases microwaves, and then on increases, this is on radio waves. If wavelength decreases, then it is a UV rays, okay, and then decreases, it is X-ray, and then there's it is decreases, it is a gamma rays. So there are 7 colors. Generally we indicate it by the Vibgyor formula, okay, and Vibgyor indicate the 7 colors, that is the violet color, indigo color, blue color, green color, yellow color, orange color, and red colors. So these are the range of the colors which can be identify and which can be easily see by the naked eyes. Okay, so next is the formula. That is the we know that the Planck's formula E is equal to h nu. Okay, this is give the relation between the wavelength and the frequency. The wavelength and frequency is also one of the most important parts, because some some of the colors having the highest wavelength, okay, high wavelength, and some having the short wavelength. Short wavelength, but wavelength and frequency are inversely proportional to each other. Okay, as the wavelength increases, frequency decreases. So there are formulas. Then the energy is equal to E is equal to h nu, where the h is the Planck constant, c is the velocity of the light, v is the frequency, and nu is the wavelength of the lights. So what happens when the light is fall on the surface? What happen in that cases? So if the light is completely reflected on the surfaces without absorptions, then that surface appear white. Then that surface is appear white in colors. Okay. If the light is completely absorbed, because this phenomena is that light absorption, light reflections is most important. If we are having 7 colors, okay, and light is falling on the 7 colors, okay, and then reflected, and our eye catches that wavelengths, the eye can be easily identify that 7 colors. Means the reflection is the most important part. If that particular wavelength of the light is not reflected, then how we can identify the which types of the colors are there. So reflection is the most important part is there. So if the part of the light completely absorbed and no light is reflected, then the surface is appear as the black. Okay, so in the black, whenever we see the black, it means that there is no light is falling on any surfaces. जब भी कभी हमको अंधेरा दिखता है तो हम क्या समझते हैं, रोशनी ही नहीं है, रोशनी ही नहीं है, मतलब कोई भी लाइट सोर्स नहीं है, कोई भी लाइट सोर्स नहीं है, मतलब कोई भी लाइट जो है कोई भी सरफेस के ऊपर जाकर गिर नहीं रही है, गिर नहीं रही है इसलिए रिफ्लेक्ट नहीं हो रही है. इसका मीनिंग क्या है, गिर भी रही होती और पूरा के पूरा 100% एब्जॉर्प्शन होता तो हमको वो चीज़ जो है डार्क दिखती, इसलिए रात के टाइम में हमको सारी चीज़ें डार्क दिखती। या फिर एब्जॉर्प्शन इंक्रीज हो गया, 100% एब्जॉर्प्शन हो गया, तब भी हमको सारी चीज़ें जो है ब्लैक दिखती है। या कोई पर्टिकुलर चीज़ हम देख रहे हैं, बाकी चीज़ें हमको दिख रही है, कोई एक पर्टिकुलर चीज़ रखी हुई है सामने लेकिन हमको ब्लैक दिख रही है, इसका मतलब उसका एब्जॉर्प्शन जो है 100% है, पूरा की पूरा वो उसको एब्जॉर्ब कर रही है। इफ द पार्ट ऑफ द लाइट एब्जॉर्ब एंड रिमेन पार्ट इज रिफ्लेक्टेड, if a part of the light is absorbed and the remaining part is reflected, then surface is colored. Thus, the color is caused due to the selective absorption in the visible range. There is a relation between the color absorbed and the color visualized. The color absorbed and color seen are called as the complementary colors. कॉम्प्लीमेंट्री कलर्स बहुत ज्यादा इंपॉर्टेंट है, कौन सा कलर एब्जॉर्ब हुआ उसका कॉम्प्लीमेंट्री कलर हमको दिखेगा। ओके, अब कैसा समझ में आएगा कॉम्प्लीमेंट्री कलर का, तो कॉम्प्लीमेंट्री कलर की यहाँ पे रेंज दी वाली है। वायलेट अगर जो एब्जॉर्ब हुआ तो हमको येलो ग्रीन दिखेगा। ओके, ब्लू एब्जॉर्ब हुआ तो येलो दिखेगा, ग्रीन ब्लू एब्जॉर्ब हुआ तो ऑरेंज दिखेगा, ब्लू ग्रीन एब्जॉर्ब हुआ तो रेड दिखेगा, ग्रीन एब्जॉर्ब हुआ तो पर्पल दिखेगा, येलो ग्रीन एब्जॉर्ब हुआ तो ब्लू दिखेगा, येलो एब्जॉर्ब हुआ तो ब्लू दिखेगा, ऑरेंज एब्जॉर्ब हुआ तो ग्रीन ब्लू दिखेगा, रेड एब्जॉर्ब हुआ तो ब्लू ग्रीन दिखेगा। तो हम क्या करेंगे, हमको अगर जो कलर आगे वाला प्लांट है, प्लांट का कलर हमको अगर जो क्या दिख रहा है, हमको लग रहा है कि प्लांट का कलर क्या होना चाहिए, ग्रीन कलर है। ओके, समवट ब्लू ग्रीन कलर है। तो ऐसे केसेस में हम क्या बोलेंगे, इसने कौन सा कलर अब्जॉर्ब किया होगा, उसका कॉम्प्लीमेंट्री कलर उसने अब्जॉर्ब किया होगा सनरेज से, उसका कॉम्प्लीमेंट्री कलर कौन सा है, ऑरेंज कलर है। तो इस तरह से हम उसको सोचते हैं कि ये कलर उसमें फॉल हुआ होगा तो ये कलर वहां से कॉम्प्लीमेंट्री कलर हमको दिख रहा है। ओके, so complementary color is give the indications. Okay, this color is caused due to the selective absorption in the visible regions, and there is a relation between the color absorbed and the color visualized, and the color absorbed and the color seen are called as complementary colors. And thus, if a particular color is absorbed, then it is a complementary color is actually seen. For example, the leaves absorb the red portion of the visible range and hence appear green, which is a complementary color. If two colors which are complementary are mixed, then white color is produced. इस तरह से ये complementary color कौन सा कलर किसको दिखेगा ये आपको समझ में आएगा। उसके बाद नेक्स्ट इज द रिलेशन बिटवीन द कलर एंड द केमिकल कंस्टिट्यूएंट। What is the relation between the color and the chemical constituents? Color is the property, okay, of the molecular property, and color of the compounds, which is generally depends upon the structure, okay, molecular structure, and there are a number of the theories which explain the relation between the color and the constitutions. So one of the important theory is the Wits Chromophore theory. So this theory explain the color relations to the structures, and the color organic compounds are called as the chromogens. Okay, chromogens are called as the color organic compounds, and this is caused due to the presence of the unsaturated groups or the chromophores if they are present. We have discussed the chromophore concept. Chromo means the color and phores means the bearers. In the similarly, if there are saturated compounds that having the oxochromes, oxo means augmented and chroma means color. So there are two types are there. One is the chromophore and one is the oxochrome. These are the groups attached to the structures of the particular molecules and help to identify the colors. So what are the chromophore and what are the oxochrome is simply we can identify here. Okay. Here are the N double bond N azo is the chromophore, N double bond O nitro is the also chromophore, C double bond S thio is the chromophore, CH double bond N azomethine is the chromophore, C double bond O carbonyl is the chromophore, N double bond O nitroso is the chromophore, C double bond C ethylene is the chromophore. Then the oxochromes are the simple compounds having the lone pair of electrons. Okay, or these are the saturated compounds. Saturated compounds are the oxochromes, that is amine, okay, methylamine, dimethylamine, sulfuric acids, chloro, methyl, okay, hydroxy group, carboxylic group. These are the oxochromic groups. So you can easily identify the chromophore and oxochromes. In simple language में बोला जाए तो जहां पर आपको डबल बॉन्डेड स्ट्रक्चर दिखेगा, डबल बॉन्डेड ग्रुप अटैच दिखेंगे रिंग स्ट्रक्चर को, तो उसको हम जो है डबल बॉन्डेड है, अनसैचुरेटेड है, उसको हम जनरली समझने के लिए क्रोमोफोर बोल सकते हैं। जो सिंपल है, जिसके पास लोन पेयर ऑफ इलेक्ट्रॉन है, सैचुरेटेड है, उसको हम जनरली एक्सोक्रोम बोल सकते हैं। So these groups may be the acidic or the basic groups, okay, and they are help to the improve the dye fiber affinity, and the compound is colored if the chromophore and oxochromes are conjugated to each other. Many times there is a precursor to the dye which can be reversibly oxidized into the dye, and the dye can also produce back to this colored compound called as a leucobase. For example, here the hydrobenzene hydrobenzene is a simple one. Okay, hydrobenzene is the simple one. We converted hydrobenzene into azobenzene. At that time there is a N double bond N group attached in between the two benzene ring. Okay, this N double bond N is act as the what, chromophore, and chromophore means chromogens. Next theory is the Armstrong theory. Okay, the color of the compound is due to the presence of the क्यूनॉइड टाइप्स ऑफ द स्ट्रक्चर्स। आर्मस्ट्रॉन्ग थ्योरी क्या बताती है कि जो कलर है वो किसके वजह से, क्यूनॉइड टाइप ऑफ स्ट्रक्चर यानी आर्थोपैरा स्ट्रक्चर की वजह से उसको कलर है, कोई भी कंपाउंड के स्ट्रक्चर को कलर है। ओके, दिस वाज बेस्ड ऑन द ऑब्जर्वेशन दैट बेंजीन इज कलरलेस। अब बेंजीन रिंग है, बेंजीन रिंग को कोई भी ग्रुप अटैच होता है क्या? बेंजीन जब हम नाम ले रहे हैं इसका मतलब सिर्फ उसको हाइड्रोजन अटैच है, उसको दूसरा कोई भी ग्रुप अटैच नहीं। तो ऐसे टाइम में बेंजीन का जो है कलर क्या है ना, कलरलेस, कोई भी कलर नहीं है उसको। ओके, अब जब हम क्या करेंगे, whereas the benzoquinone is a येलो कलर, बेंजोक्यूनोन उसको कीटोनिक ग्रुप अगर जो हमने अटैच कर दिए, ओके, उसको कीटोनिक ग्रुप हमने अगर जो अटैच कर दिए बेंजीन रिंग को, तो उसको कलर आ गया, उसको कलर आ गया येलो कलर। ओके, ये ग्रुप अटैच करने की वजह से उसको कलर आ गया। तो क्यूनॉइड टाइप्स ऑफ द स्ट्रक्चर अगर जो है क्यूनॉइड टाइप्स का, तो उसमें कलर आ जाता है। जस्ट अकॉर्डिंग टू दिस थ्योरी एरोमेटिक कंपाउंड यानी बेंजोनॉइड स्ट्रक्चर विच कैन चेंज इनटू द क्यूनॉइड स्ट्रक्चर्स यानी कलर स्ट्रक्चर में कन्वर्ट हो सकता है। द क्यूनॉइड रिंग ओनली कॉम्बिनेशन ऑफ द क्रोमोफोर। अभी उसको अगर जो कोई क्रोमोफोरिक ग्रुप अटैच है बेंजीन रिंग को, तब जाके वो क्यूनॉइड स्ट्रक्चर बन जाएंगे। तो अकॉर्डिंग टू द आर्मस्ट्रॉन्ग थ्योरी कैन बी कंसिडर्ड एज द एक्सटेंशन ऑफ द क्रोमोफोर थ्योरी। Hence this is called as क्यूनॉइड थ्योरी और टू एक्सप्लेन द कॉज ऑफ द कलर इन द कंपाउंड। अब देखिए यहाँ पर बेंजीन रिंग की ही एक्सटेंशन किया हुआ है, सारे जो स्ट्रक्चर है बेंजीन रिंग के हैं लेकिन एक्सटेंशन है। बेंजोक्यूनोन, ओके, ऑर्थोक्यूनॉइड स्ट्रक्चर, पैराबेंजोक्यूनोन, पैराक्यूनॉइड स्ट्रक्चर, these are all the extension of the benzene rings। तो क्यूनॉइड स्ट्रक्चर फॉर्म हुआ है तो इसको कुछ ना कुछ कलर रहेगा, ये कलर लेस कंपाउंड नहीं रहेंगे। तो when phenolphthalein is present in the benzonoid form it is colorless। phenolphthalein अगर जो कलरलेस फॉर्म में है, ओके, phenolphthalein is present in the benzonoid form, बेंजीन के फॉर्म में है तो वो कलरलेस रहेंगी। बट इट इज सोडियम सॉल्ट कैन एज्यूम क्यूनॉइड स्ट्रक्चर। अगर जो अब ये फर्स्ट स्ट्रक्चर है फेनोप्थेलिन का, उसमें हमने सोडियम ऐड कर दिए तो सोडियम सॉल्ट तैयार हो गया। तो सोडियम सॉल्ट तैयार होते ही वहां पर क्या हो गया, उसको कलर आ गया। हेंस कलर इज लुक लाइक अ कलर पिंक कलर और अल्कलाइन मीडियम। तो अल्कलाइन मीडियम में उसको कलर, इस तरह से कलर्स आते हैं हम जो देखते हैं ना स्ट्रक्चर्स कंपाउंड्स हो, लिक्विड्स प्रैक्टिकल परफॉर्म करते वक्त जो कलर जो आते हैं वो कलर के भी पीछे की थ्योरी इसी तरह से होती है कि कोई ना कोई वहाँ पर सॉल्ट तैयार हो जाता है, कोई ना कोई ग्रुप उसको स्ट्रक्चर पे ऐड हो जाता है। ओके, कोई ना कोई क्रोमोफोर उस पे ऐड होता है जिसकी वजह से उसको कलर आ जाता है। तो फेनोल्फथैलीन जो था स्टार्टिंग में वो कलरलेस था, जैसे ही उसको सोडियम सॉल्ट बना दिए, सोडियम सॉल्ट ऑफ द फेनोल्फथैलीन, तो तब उसको पिंक कलर आ गया। However, Armstrong theory has the following limitations. उसको limitation है जैसा कि iminoquinone and diiminoquinone have the quinoid structure yet they are colorless. ये colorless है compound. उसके बाद there are large number of the colorless compound but they cannot be represented by the quinoid structures. बहुत सारे ऐसे कंपाउंड है जो कलर वाले हैं लेकिन उसके ऊपर क्विनोइड स्ट्रक्चर का कोई नामो निशान नहीं है। An attempt to explain the color of the paranitrophenol failed. There was no evidence for the corresponding quinoid structures. ओके, पैरानाइट्रोफेनॉल के केस में भी कोई प्रूफ नहीं है कि वो क्यूनॉइड स्ट्रक्चर को शो करता है। क्यूनॉइड स्ट्रक्चर है फिर भी वो कलरलेस है। ठीक है, तब भी वहां पे कोई थ्योरी एक्सप्लेन नहीं है करने के लिए। अकॉर्डिंग टू द आर्मस्ट्रॉन्ग थ्योरी के हिसाब से ये उसका फेल्यूर है। अब नेक्स्ट थ्योरी है वैलेंस बॉन्ड थ्योरी। तो अकॉर्डिंग टू वैलेंस बॉन्ड थ्योरी, वैलेंस बॉन्ड थ्योरी हमने इससे पहले भी पढ़ा है। ओके, वैलेंसी के बारे में वैलेंस बॉन्ड थ्योरी, यहाँ पर ये थ्योरी कलर के बारे में बात कर रही है। कलर इज कॉज्ड बाय द एब्जॉर्प्शन ऑफ द विजिबल रेडिएशंस by the molecules. This energy is utilized in the electronic excitation of the molecule. In the valence bond theory, the electrons are considered in the pair, and due to the absorption of the visible radiations, the color are transferred from ground state to the excited state, and the energy required for such a transition depend on the molecular structure. The energy required is quantized. Energy is equal to energy of the ground state, energy of the excited state minus energy of the ground state, means energy is equal to difference between the excited state and the ground state, that is h nu, and h nu is equal to, we know that, sc divided by lambda. So thus the particular radiations means the energy provided a specific amount of energy, and the energy of the UV radiation is greater than the visible radiations. In visible range, violet light has higher energy than the red light. Okay? रेड लाइट से जो है कौन से वायलेट कलर की लाइट की जो है रेडिएशंस की जो एनर्जी होती है वो ज़्यादा होती है। सो द एक्साइटेशन ऑफ द इलेक्ट्रॉन्स in the saturated molecule is very difficult as they require higher energy, hence they absorb only in the ultraviolet region and they are colorless. The excitation of the pi electrons of the double bond is easier as they are loosely held and mobiles, hence the unsaturated molecule absorb in the visible range and they show the color. Similarly, non-bonding electrons on the oxygen, sulfur and nitrogen are also easily excited, and this explains how the color in the molecule which chromophore is caused. The color of the compound will be the obviously complementary to the color absorbed. So this theory is explained that the compound, if the unsaturated at that times, there is required more amount of energy to break that particular bond, means to break that, to excite that particular electron. If molecule having the pi electrons are the loosely held, they can easily excited, means in this cases saturated compounds is colorless and the unsaturated compound can be visible, can be seen as the color. In some cases, like if there are group attached, that is oxochromic group or chromophoric group having the lone pair or non-bonding electrons, then bonding electrons is also can be excited, and that can also be impart the color to the particular molecules. This theory explains, that is valence bond theory explains. If it is found that the color of the compound and its intensity varies with the variation in the structures, and thus if the groups are added or the removed, or if more double bond are introduced in the conjugation, the color changes. Means the total game is depend upon the conjugation systems. If the more conjugation, color can be increased, intensity also can be increased. So here the increase in the wavelength of the absorption of the light is called as bathochromic shift, and the opposite of this is called as hypsochromic shift, means yellow, orange, red, purples, violet, blue, and greens. The wavelength is increases means the it is moves toward the bathochromic shift, and the wavelength is the opposing means decreasing. It is called as hypsochromic shift. Similarly, if the intensity of the color is increases, that is the color becoming dark, then it is called as hyperchromic shift. And if the intensity is reduced, that is it is called as the hypochromic shift. So these are the shift which indicate the color intensity and the wavelength. Okay, wavelength increases, color intensity increases, that indicated by the shift, that is the hypsochromic shift, hypochromic shift. Okay, and the valence bond theory in the relation between the color and the structure can be explained by the resonance. It is a phenomenon by which the number of charged and the uncharged structure can be written which have the same. Here the combined structure wavelength indicated that the how the intensity is increases is hypochromic, intensity decreases hypochromic, wavelength is increases bathochromic, wavelength decreases hypsochromic shift are there. So another important factor which affect the transition of the electron in the molecule is dipole moment. A molecule can be absorb the light only when its dipole moment changes, resulting in the transition dipole moment. And this turns depends on the symmetry of the molecules. If the molecule is symmetrical, then the possible of the transition dipole is very less because there is no charge separation is there. So, but in case of the unsymmetrical molecule, there will be the changes in the dipole moment, and transition dipole is formed. Hence, the intensity of the absorbed light will be increased, and if the charge structures are more, the color of the compound deepens. So in resonance theory of the chromophore is considered as the electron withdrawing groups and oxochrome as an electron donating group. When they are conjugated, they are double bonds, means they increases the conjugation in the molecule. This increases the resonance structure and also cause the changes in the dipole moment, and hence the intensity of the color is increases. And if the interaction between the chromophore and oxochrome is increases, the resonance increases and increases the intensity. Here is the example which can explain this concept. Here in this example, there is a benzene ring attached with the NO2 group which is act as the chromophore, and another group is the NH2, it is act as the oxochrome. So oxochrome is involved in the conjugations there, and in the benzene ring there are four conjugations, but as we attach the oxochrome and chromophore, conjugation is increases by the two, means as the conjugation increases, color is imparted to the particular color. So this develop the color in the compounds and can explain with the help of resonance of the follows. तो जहाँ पे भी कोई भी कंपाउंड में अगर जो ऑक्सोक्रोमिक ग्रुप और क्रोमोफोर्मिक ग्रुप दिखा, तो आप वहाँ पे क्या गैस लगा सकते हैं कि कंपाउंड के अंदर जो है कलर इम्पार्ट हो सकता, कलर वहाँ पर आ सकता।